So in this question, you have to write an expression for the time taken in terms of t for the ball to roll down a distance s by 2. Look, if a ball roll complete distance s, so we have the formula s is equals to ut plus half at square, the formula which relate the time and the distance. Initial velocity is 0, so if initial velocity is 0, it means the s, the distance which the ball travel, the total distance, is equals to u 0, the initial velocity. So if u is 0, this whole factor ut will be 0, so we'll have half at square. A is the acceleration which is constant on inclined surface. If there is no friction, A is equals to g sine theta. So means the acceleration will not change. The time, this 1 by 2 is a fraction that also remains same. So if we want to find the half of the distance, like the time taken to cover half of distance, because we need s by 2. So what should be the change in the time so that this whole fraction will become half? So we have s is equals to half at square. We want the distance to be half. If I want distance to be half, I want this whole fraction, whole like half at square should also be half, because that is the total time it will take to complete. But I want this also to be half. But how this can be half? 1 by 2 cannot be changed. A cannot be changed. The only thing which can change here is time. So how a time will change so that the distance will be half? So if we want this to be half, the time should change by square root of the 2. Why square root of the 2? Because the t square is there. So when time become, or time is divided by square of the root of the 2, what will happen to the whole fraction? As you can see, when I substitute, so if I want s by 2, it is 1 by 2a, and the time, because this whole factor I want to be half. So if time is become t by square root over 2 square, so it will become half a t square by, and square root over 2 cancel with square, so that will become 2. So you can see whole fraction will become half. So what should be the time taken, or the time should it decrease, change? So it will be t, the total time divided by square root of the 2. Is it clear? Because what we want, we have this formula s is equals to ut plus half at square, u is 0, so it will become half at square. I want this distance to be half, because that is a, so I want the this time taken for distance to half. So what should happen to this time when the distance is half? So if I say this time should be divided by 2, if this time is divided by 2, the distance will not be half, distance will be quarter. Why? Because a and t, half and a are constant, so basically s is equals to proportional to t square. So if time is multiply, or if time is divided by 2, so what will happen to distance? Because it vary with the square, so 2 square is 4, so distance will divide by 4, so it will not be correct. We want this to be half. So if you want this to be half, so it should be divided by square root of the 2, because when it is divided by square root of the 2, the distance will be s by 2. So the time taken will be the total time divided by square root of the 2, that will be the time taken by this object to move on the inclined surface when it cover half of the distance. Is it clear? Is it clear this point? The Galileo repeated his measurements many times and obtained a similar result on each occasion. He did not have a stopwatch and had to measure a time using his pulse. A human pulse is about 1 beat per second. So he's using a pulse. So 1 beat per second means like he's counting the number of the beats, and that is a time interval. But the disadvantage of this method, he cannot measure a time interval which is less than 1 second, because there is nothing half beat or quarter beat. So the comment on the Galileo method. So first thing, 1 beat per second means the time interval in a fraction cannot be measured precisely. Because like example, if an object was taking 1.5 seconds, so how he can measure 1.5 second? He cannot identify 1.5. It's always a whole number. So it will not be precise or accurate. And second thing, he's using a like a human pulse is used. So maybe the pulses are not same. A variation is there in a pulse from one day to another. So like example, if one day, if he's having the pulse or a heart is beating at a higher rate, so the example, he got 10 pulse, so he will consider 10 second. Another day, the same 10 pulse, but it's taking a longer time, so he also think that is also 10 second. Is it clear? the the part like Galileo repeated. So 1 beat per second means a time interval. And the second thing, variation in the pulse. Like the pulse is not always a constant rate, so variation in the pulse rate is there. And another thing, he's getting a similar result. So if he's getting a similar result, he's precise, results are precise or precision here. Like example, getting the similar answer, so results are precise. So this is a comment on the Galileo method. Then today, the acceleration of a free fall can be found accurately by dropping a metal ball vertically and using ICT to collect data. Suggest the apparatus required to make the measurement needed to calculate a value for acceleration of a free fall. So using this ICT, how we can measure, as we discussed, finding the acceleration of a free fall and acceleration due to the gravity. First thing, we want to measure a distance and the time, because using this we can work out the formula. S is equals to ut plus half at square if initial is 0. So S is equals to 1 by 2 gt square. So we want to measure a time and we want to measure distance it will take to fall. So what we can use a light gates to measure a time, or we can use a tap switch, electromagnetic method, if you remember, to we can measure a time interval. Or we can also use a camera and capture the frame per second. So frame per second multiplied by number of frames which are captured. We can also work out the time interval. And distance can be measured by a ruler or a scale. Is it clear, this method? Page 31, question 25. A tennis ball is thrown vertically upward. So the question is, which row is actually representing the direction of velocity and acceleration of a tennis ball while it's moving upward? Look, when objects are moving upward, they tend to decelerate. Decelerate means the speed decreases, velocity or magnitude decreases. So decelerating up or accelerating down having a same meaning. Because decelerating up means it is more, the resultant force is opposite to direction of the motion. Accelerating down means the resultant force is same as the direction of the motion. So both cases, the resultant force is acting down, and what is the resultant force? That is a gravitational pull or the weight of the object. So direction of acceleration will be downward, because when it's moving upward, it will decelerate. So decelerating up means accelerating down. The direction of the velocity, because velocity, the displacement in a unit time. So in a short time, displacement in a unit time, it's going up. So if object is going up, so velocity is upward. So acceleration is downward, but velocity is upward. That's why 25C is the right answer. Is it clear? This was an exercise related to motion, graph, and force. Any other question? If I miss any of them, you can just point it out. Otherwise, I will start the explanation of the new topic. Is it clear? Or any other question you have a doubt?